5 to the power of k plus 5 to the power of 2k plus 5 to the power of 3k is equals to 155. We want to find the value of k. Solution. Let's get down the question first. 5 to the power of k plus 5 to the power of 2k plus 5 to the power of 3k is equals to 155. 5 to the power of k plus 5 to the power of 2k could be written as 5 to the power of k times 2 plus 5 to the power of 3k could be written as 5 to the power of k times 3 equal to 155. Now, you will see that 5 to the power of k is common. So, let's suppose 5 to the power of k is equals to x. This means that in place of 5 to the power of k, we just write what? We write x. So that will be x plus x to the power of 2 plus x to the power of 3 equal to 155. Let's proceed further. X plus x to the power of 2 plus x to the power of 3 is equals to. Now, let us focus our attention on 155. 155 could be written as 5 plus 25 plus 125. X plus x to the power of 2 plus x to the power of 3 is equals to 5 plus, I can rewrite 25 as 5 square plus, I can also rewrite 125 as 5 to the power of 3. This means that. Now, let us rearrange these equations. We have x, moving 5 to the left hand side, that becomes minus 5. We can put it in brackets. Plus s square, moving 5 square to the left hand side, that will be minus 5 square. Let's put it in brackets too. Plus x to the power of 3, moving 5 to the power of 3 to the left hand side, we have minus 5 to the power of 3. Let's put it in brackets also. This equals to 0. Welcome. Pamela, welcome. Let's continue. Now, let us recall some identity. The first identity is a square minus b square. This is equals to a minus b times a plus b. The second identity is difference of 2 cube. A to the power of 3 minus b to the power of 3 is equals to a minus b times a square plus ab plus b square. Take note of these two identities. From this line now, we have x minus 5 plus, applying this identity to this guy, we simply have x minus 5 times x plus 5 plus. Now, let us apply the second identity to this guy. Doing that, we simply have x minus 5 times s square minus 5x plus 5 square. Everything equal to 0. Let's proceed further. We have x minus 5 plus x minus 5 times x plus 5 plus x minus 5 times s square minus 5x plus, what is 5 square? 5 times 5, 25, equal to 0. You will see that something is very common here, that is x minus 5. It is common throughout. We can pull it out. So that will be x minus 5 into, in place of x minus 5 now, we write 1 plus x plus 5 plus s square minus 5x plus 25, close the brackets, equal to 0. Let's proceed further. X minus 5. Now let us drop these square brackets. So we have 1 plus, dropping these round brackets, we have x plus 5 plus, dropping this round bracket also, we have x square, this is square, minus 5x plus 25 equal to 0. So x minus 5 times x, this is x square, x minus 5x, oh, there is a mistake here. This has to be um, plus. We have plus because of this identity. We have plus. We have plus. So let's continue. Sorry about that. So let us add the common terms. X plus 5x, that is 6x. And let us add this constant to 1 plus 5, that is 6, plus 25, that is 31, plus 31 equal to 0. Let's proceed further. This implies that x minus 5 is equals to 0, or s squared plus 6x plus 31 is equals to 0. From this linear equation, it is obvious x is equals to 5. But our main goal is to find what? Is to find k. So since we know that 5 to the power of k is equals to x, let me show you where we got this from. It's from this assumption that we first made. Let's continue. This implies that 5 to the power of k is equals to, in place of x, we write 5. 5 to the power of k is equals to 5 could be written as 5 to the power of 1. Now, since the base is the same, that means the power must be equal. So k is equals to 1. This is the first solution. K is equals to 1. Now, let us consider this quadratic equation. Let's solve it using completing the square method. So let's separate this. So by completing the square method, let me just write square. We have to, the first step is that we transfer the constant to the right hand side. X squared plus 6x equal to minus 31. The second step is that we gonna add half of the coefficients of x and at the same time square it to both sides. The coefficient of x here is 6 and half of it will be 6 divided by 2 and we square it. So add this to both sides. So doing that we have x squared plus 6x plus 6 over 2 all squared equal to minus 31 plus 6 over 2 all squared. So let's proceed further. I can combine this left hand side. So that will be x plus 6 over 2 all squared equal to minus 31 plus 6 over 2 all squared. That is, when you expand this left hand side very well, you're gonna have all of this back. Let's proceed further. X plus 6 divided by 2, that is 3, all squared equal to minus 31 plus 6 divided by 2, that is 3, and we have squared. X plus 3 all squared equal to minus 31 plus, what is 3 squared? 3 times 3, 9. So we have x plus 3 all squared equal to minus 31. Okay, minus 31 plus 9, that is minus 22. Minus 22. Now let us take square root of both sides. Taking square root of both sides. So that will be x plus 3 equal to plus or minus square root of minus 22. This means that x plus 3 is equals to plus or minus. I can rewrite minus the square root of minus 22 as square root of minus 1 times square root of 22. X plus 3 is equals to plus or minus. What is square root of minus 1? From the complex number, we know that square root of minus 1 is equals to I. So we have I here times square root of 22. This implies that x is equals to, moving this 3 to the right hand side, we have minus 3 plus or minus I times square root of 22. So let's proceed further. From here, it is obvious. Okay, let us find the value of m now. So, okay, k rather, sorry about that. Since 5 to the power of k is equals to x, because we want to find the value of k. This means that 5 to the power of k is equals to, so in place of x now, we write what? We write minus 3 plus or minus I times square root of 22 minus 3 plus or minus I times square root of 22. If we take natural log of both sides, so that will be log 5 to the power of k equal to natural log of this minus 3 plus or minus I times square root of 22. Recall that log a to the power of m is equals to m times log a. Using this identity on this left hand side, that would be k times log 5 equal to log of minus 3 plus or minus I times square root of 22. Now, let us divide both sides by log 5. Doing that, we have k equal to log of minus 3 plus or minus I times square root of 22 divided by what? Divided by log 5 divided by log 5. At this stage, let us record this very beautiful identity. It says log a divided by log b. This is equal to log a base b. You can see it is very beautiful. From this line now, we have k equal to, applying this identity to this guy, this quotient, we simply have log of minus 3 plus or minus I times square root of 22 base 5. This is another set of solutions. This implies that k equals to, considering this positive sign, first we have log of minus 3 plus I times square root of 22 base 5. Considering the negative sign, we have k to be equal to log of minus 3 minus I times square root of 22 base 5. This is another solution. Let's call it the second solution. And this is the third solution. Let me show you the fourth solution that we obtained. K is equals to 1 solution. So therefore, all the solutions that we have for this exponential equation are: the first one, k1 is equals to 1. The second solution, k2 is equals to what we have here, log of minus 3 plus I times square root of 22 base 5. The third solution, k3, equal to log of minus 3 minus I times square root of 22 base 5. You will see that we have three distinct solutions for this equation. Let's verify at least one of the answer that we got. Let's verify this first solution. K equals to 1. Verify. Using the original equation, 5 to the power of k plus 5 to the power of 2k plus 5 to the power of 3k equals to 155. So let us verify k equals to 1. When k is equals to 1, plug in the value of k into this exponent. That will be 5 to the power of 1 plus 5 to the power of 2 into 1 plus 5 to the power of 3 into 1 equals to 155. This is our claim. What is 5 to the power of 1? That is simply 5 plus 2 times 1, 2. 5 to the power of 2, that is 25, plus 3 times 1, 3. 5 to the power of 3 is 125. This equals to our claim, 155. Let us add the left hand side together. 5 plus 25, 30. 30 plus 125, that is 155. 155 equal to 155. You will see that the left hand side is the same thing as the right hand side. That means the first solution is correct. The second solution also is indeed correct, and the third solution. That's it for this video. Thank you so much, guys, for joining this live session video. Please share your tips and please tell me if this video was helpful. And don't forget to like and subscribe to my channel. I would love to see you in my other videos as well. Have a good one.